So let's look at the problem. X squared plus y cubed equals 4. And let's say the problem is asking us to find the derivative of this whole thing. So now, as you can see here, this is a unique type of problem. We have both the x squared and the y cubed. We have two variables. So this means that we cannot just use our normal power rule or chain rule in order to figure out what the derivative is for this expression. In order to do, or this is not an expression, this is an equation. So we can't just use a normal derivative rule that we know from our past to solve basically the derivative for this equation. So now what do we use then? Well, we use implicit differentiation. So now what is implicit differentiation? Well, let's take a look at that. So implicit differentiation is used whenever we have two different variables, as we see here with x squared and y cubed. So now let me give you a small example of how we solve this. So let's say that we need to find the derivative in terms of x. This is super important. You have to always look at this and see that which one are we finding the derivative for and in what terms is it in. So the problem is telling us to find the derivative in terms of x. So let's use the normal power rule for the x variable. So that would just be bring the 2 down, x minus 1 on top, so it's just 2x plus, okay, so now we have the y cubed. Now since this is in terms of x, what we need to do is first let's use the power rule for y cubed, which is nothing but 3y squared. However, now we need to add dy over dt. Because it's in terms of x, but we found this in terms of y now. So we need to add that dy over dt. Now equals, now you should know by now the derivative of a constant is just 0. So hopefully this makes sense. Whenever, which variable in terms you're trying to find for, you use the normal power rule, but the opposite variable, not opposite variable necessarily, but the other variables, you would have to add a dy over dt in order to make it in terms of d over dx. So let's move on. So we have 2x plus 3y squared plus dy over dt equals 0. So now what do we do next? Well, here's the catch. So after finding this local derivative for each term, we need to now solve for dy over dt. This is a normal standard rule that we need to follow when using implicit differentiation. So let's do that. So then let's do 3y squared dy over dt equals, let's bring the 2x to the other side, so this is minus 2x. So now if I come back up here, dy over dt is equal to negative 2x minus 3y squared. So let me just make some space. So what we get is the final answer for this one is dy over dt is equal to negative 2x minus 3y squared. And that is our answer. This is how we use implicit differentiation. So as you can see here, we had a two-variable equation or a function. Then we had to find the derivative in terms of x. We used the normal power rule there. Then we had to use, this is the real implicit differentiation, right? This is the real implicit differentiation. You find the derivative using the power rule, but then you have to add the dy over dt. And finally, the last step is to solve for dy over dt, and that is our derivative function. Thank you for listening to this video on ASAP Physics.